My name is Mark A. Allen. I am an economist and engineer by undergraduate training, and more recently am one of the primary developers of Life 365 version 2.0. We want to give credit to Evan Bentz and Michael Thomas for their initial work in the software. To summarize, we've got a service life of 68 years for the alternative one and 15 years. What we want to know is whether or not in the field variations could flip that, where there's enough variation in the field that alternative one is not life cycle cost effective, doesn't have the longest service life under some conditions. So the way we do that, and it's relatively quick, is you press this compute uncertainty button. And you'll first get a screen here that shows you, that asks you, do you want to compute this uncertainty? And it tells you a little bit about why it's asking you. This is a little advanced. It's important to understand what it's doing. And depending on your computer, it may take a little bit longer. And what it's doing here in the lower left-hand corner, you'll see it's computing for each alternative. It's doing 5 different calculations. It's modifying M, D28, surface chloride concentration, the chloride necessary to initiate corrosion, and the depth of reinforcing. It's modifying each of those to come up with this probability function. So in addition to those other tabs you had before, it's added in a tab here of graphs that show you the variations in service life. So the one here on the left shows you for each year, and we're going up to 75 years because that's our study period. For each year, what's the probability of the alternative having that service life? So in this case, it's showing that the base case peaks out much lower. It's got a service life its most probable service life is on the order of 13, 14 years. Alternative one is more interesting by far. It's much flatter and much wider. And by looking at these two, just visually at these two, it's very hard to tell which one has a longer service life in a probabilistic sense. The statistical way to get a direct answer to that is to do the cumulative service life probability. The quickest way to determine which alternative has the longest service life in a probabilistic sense is to see if one of these lines is below all the other lines. So in this particular graph, you'll see that the blue line is below the red line for all values except for very low values here. You can see that the blue line here is higher. And you can actually zoom in on these by lassoing around that and getting closer. So you can see down in 7 years or less, the blue line is higher. What this is saying statistically, if this line is below all the others, it has the longest service life in a probabilistic sense. And that's your answer. Statistically, when you're at the 50% value here, that there's a 50% chance, because it is the mean value, these table values are the mean values of those distributions. So at the 50%, these should match up here with the service lives, because at that value, you've got a 50% chance of being less than that service life and a 50% chance of being more. And statistically, that means it is the mean value. In this case, it is the best guess value. All right, now that we know the uncertainty and service life of the concrete, we want to know, and we know that this alternative has the longest service life in a probabilistic sense. We want to know whether or not this alternative one, this concrete mixture, is life cycle cost effective in a probabilistic sense as well. And the way we do that is we can go to the life cycle cost tab, which we've seen before, and you'll notice here on the bottom now we've got those same distributions. And we've got the ability to run a slider here. So I'm going to click on cumulative probabilities, which just means we get to see this graph here, the one we saw before. And the blue line is still below the red line. So at the 50%, it's showing you dotted lines at the 50% values. In this case, it is the 15 years, which is very close to the 14.6 we had. And here it's showing you the 67 or 68. At those values, remember from before, we saw that alternative one had a lower life cycle cost than the base case. What we want to do is modify those probability and see if the blue still has a lower value. So I'm going to modify to 25%. Let's check these values. The blue here is still lower than the red, which means that at 25%, this has a lower life cycle cost. Let's go to 75%. Blue still has a lower life cycle cost. We can get down to fairly low values and at some point we're going to catch where those lines cross, but even at low values, you're seeing that this is still has a lower life cycle cost. So by modifying, to summarize, to modifying these probabilities, you can see that regardless of the probabilities that we've selected, alternative one still has a lower life cycle cost. The last thing that I want to show you in terms of capability is I'm going to turn off the uncertainty calculation and recalculate, and then quickly look at the sensitivity analysis. And again, sensitivity is where we really don't know what that distribution looks like. We don't know if repair costs have a normal distribution or a uniform distribution. We have no information about it. So we essentially assume that it's uniform, and we check all of those values to see if one of those will jeopardize alternative one as a life cycle cost effective choice. So I've gone to life cycle costs. I'm going to click on the sensitivity analysis tab. And now what I'm going to do is select from one of these parameters. So let's select inflation rate. So by selecting inflation rate, the variation here is set to 100%, which means that from the initial best guess value we had, we're going to remove 100% of the inflation rate, or we're going to double it. It's going to go from 0 to double our value. So for each one of these inflation rates, I'm going to recompute the life cycle costs. So you can see here, as the inflation rate goes up, the life cycle costs go up, inflation rate goes down, life cycle costs go down. The important takeaway is that regardless of this inflation rate we've selected, alternative one always has a lower life cycle cost than the base case. So we can say, well, we don't know what the inflation rate really is going to be over the course of this project, but given this range, it doesn't matter. Alternative one is life cycle cost effective. Same thing with the discount rate. For very high discount rates, you'll see alternative one is still less than the base case. For very low discount rates, it's still lower. So our takeaway is we don't really know what the discount rate is going to be over the life of the structure. But given these changes, alternative one is still life cycle cost effective. Last one I'll check is the repair cost. In this particular structure and these concrete mixtures, for this comparison, we're modifying what it costs per square foot to make each structure. When we lower those repair costs, the life cycle cost of the base case goes down, and to a lesser degree, the alternative one as well. And it's only at very low repair costs does the base case become life cycle cost effective. So our takeaway from this is, looking at this graph, we don't really know what the repair costs are going to be over the life of the structure, but only for very, very low repair costs is base case life cycle cost effective. Let's go into the concrete mixes. And let's say we're really stuck on how this uncertainty analysis works. What is it doing? How does it do it? We can go to the online help tab here at the bottom, and we've got some categories. Go to the uncertainty analysis part, and here it gives you a detailed explanation of how we're doing uncertainty analysis, and step by step, if you were to work through the analysis, what are the steps that you should go through? So if you start the uncertainty analysis and it gives you that box that says, are you sure you want to go ahead with this? If you say to yourself, well, I'm not really quite sure, then go ahead and go to this online help, walk through this, and it'll give you very detailed explanations about how to conduct it so that when you do conduct it, you feel comfortable with it.